Good morning, everybody, and thank you for attending Danfoss's Adapt to Snap webinar. My name is Michael Beckerman, and I am the Marketing and Communications Specialist for North America. During today's interactive 60-minute session, our experts will demonstrate how to navigate the recent Snap rules, outline their implications, and ensure your compliance moving forward. Webinar attendees are muted, but your voice will be heard. We invite you to answer several poll questions that will be posed over the course of the webinar, as well as submit your questions to our subject matter experts by entering them into the chat box on the left side of your screen. We will answer a select number of your submissions at the conclusion of this session. Lastly, this webinar will be recorded. You will be emailed a copy of the session in the near future. All right, so let's get started. I am pleased to introduce the presenter for this webinar, Mark Menzer, Danfoss's Director of Public Affairs. Prior to joining Danfoss, Mark was Regional VP at Intertech Laboratories and was Executive VP for the Air Conditioning, Heating, and Refrigeration Institute, where he provided leadership for AHRI's research, standards, and product certification activities. Mark has also worked extensively with HVACR manufacturers and utilities. Mark is joined by a panel of some of our experts, including Dean Groff, Christopher Nitz, Steven Spletzer, and Jeff Staub. Their titles can be reviewed on the screen. Mark?
Thank you, Michael, and welcome. The purpose of this webinar is to explore the recent EPA SNAP rules and to discuss what they mean to commercial refrigeration equipment manufacturers. Danfoss has been working with the industry and with EPA to help them fashion regulations that help the U.S. to move to low GWP refrigerants in a predictable way, and also that will give manufacturers time to comply with these regulations, as well as with the DOE efficiency regulations. And we have asked the EPA at public meetings and in written comments to provide reasonable time to transition to the new lower GWP refrigerants. We think that this recent rule is a great improvement over the proposal that was floated last year. So this webinar will provide some of the background to the rule itself, and where we go from here. As you heard, the webinar will be interactive, so pay attention, be ready to participate. Here's what we're going to cover today, and we'll leave some time for Q&A at the end. A little background on why there even is a phase down. Then we'll get into the rule, followed by what the refrigerant options are. We'll talk about why action is needed now. And then finally, how can we help you? And then some Q&A. So let's start with a little information about you. On a scale of 1 to 5, please rate your level of familiarity with or your comprehension of the details and implications of EPA SNAP Rule 20. So how well do you know? Enter your answer with your cursor. Click on it. In a moment we'll give you the results. And here we go. A wide range from some being very familiar, some mostly not too much. And we hope we will leave you with a better understanding of what's involved with this rule by the time we're done. So why are we even having this conversation? Emissions of greenhouse gases continue to rise, and most scientists believe that there is a link between the rise of CO2 and global climate change. So the U.S. is currently emitting 6.5 billion metric tons of CO2 a year. That's what this whole pie represents, 6.5 billion metric tons. And I had trouble grasping what that really means, so I tried to make that equivalent to something that I could understand, and the heaviest thing I could think of is an aircraft carrier. So the amount of CO2 gas we put into the atmosphere a year is equal to like 76,000 of the largest aircraft carriers, if you can try to imagine that. So that's the gas that we're just emitting here in the United States. HFCs, which contribute to the small red sliver seen here, represent a very small part of the problem. Certainly, there's efforts to reduce every type of greenhouse gas emission. In fact, just last week, the Obama administration issued its Clean Power Plan, with the aim of reducing CO2 emissions by about a third in just 15 years from now. And likewise, there's efforts to reduce methane emissions, the CH4 that you see here as well as all other types of greenhouse gases. So there's efforts to get this whole pie to shrink. And here are the components of that small sliver broken out. HFCs is the first bar. So for that 2.6% of greenhouse gas emissions that we saw in the previous chart, almost all of those emissions are HFCs worldwide. Notice we use the term substitution of ozone-depleting substances on that first bar. That term, substitute, is going to come up again. Remember that the HFCs that are being phased down or phased out are themselves substitutes for the ozone-depleting CFCs and HCFCs that we used to use. EPA had the authority to control those substances, and they also have the authority to control the use of the substitutes. So there we get the term substitutes. And if you look at all the bars that make up this sector, the so-called short-lived pollutants, you'll notice that HFCs constitute about 90% of these. And HFCs are the easiest substance to regulate since they're tied to just a few industries and a few applications. And that sliver that we talked about is the fastest growing component of greenhouse gases. As shown in this NOAA chart, the speedy adoption of air conditioning and refrigeration systems around the world is leading to a rapidly growing use of HFCs. This bar near the bottom is pretty constant use in the developed world, and the big gray line towards the top is the use in the developing countries if things don't change. So I think that this chart says it all. HFCs will have to be dramatically phased down. So let's look more closely at the refrigerants we used to use, those that we're currently using, and those that we might be switching to. Today's refrigerant GWPs seem tiny compared to those of the past. And by the way, what is a GWP? A GWP, or global warming potential, is the relative contribution of 1 pound of the substance. So we assign the value of 1 to CO2, which you see towards the right of this diagram. And then we measure everything relative to that. So two things go into assigning the GWP: how effective that gas is in trapping heat in the atmosphere, and how long the molecule lasts in the atmosphere before it breaks down. And that's all the physics we're going to get into here. Of course, CFCs were banned in new equipment some time ago, and existing CFC equipment survives only on recycled service refrigerant. Although CFCs were banned because they contributed to the depletion of the Earth's ozone layer, their elimination also got rid of very potent greenhouse gases with GWPs of several thousand, as we show here. And I should probably point out that only the use of new CFCs are banned. In this case, and in fact every case of refrigerant phase-out, including the rules that we're going to talk about today, there's never been a need to immediately get rid of the old refrigerants that are in use in systems now. Nor is there a ban on the reuse of refrigerants as long as they've been properly recycled or reclaimed. Of course, all EPA rules for handling refrigerants, including technician certification and no venting rules, must be followed. The rules we're discussing today find a large number of common refrigerants unacceptable for most refrigeration applications. Refrigerants with GWPs down to around 1,400 were eliminated for certain refrigeration uses. And R22 is already being phased out through other mechanisms, but we show it here for just comparison purposes. Leaving us with options that have very low, or in some cases, nearly zero GWP. And we'll come back to this list in just a moment. First, though, let me provide you a little bit of background on SNAP. And by the way, we're going to provide these slides to attendees after the webinar, and the colored underlined phrases that you see here are links to learn more information. SNAP stands for EPA's significant new alternatives policy. EPA was given the authority and the responsibility in the Clean Air Act to continuously review alternatives to find those that pose less overall risk to human health and the environment. The process to accept a new chemical by EPA is started by someone filling out an application to have a new refrigerant accepted by them. The submitter identifies the chemical, includes its physical, its chemical properties, its uses, its availability, everything that's needed to fully evaluate its safety to people and to the environment. The performance efficiency of the refrigerant doesn't have to be submitted to EPA, although it can be. And of course, efficiency is important to us. DOE efficiency regulations have to be met, and inefficient refrigerants can be just as damaging to the environment as can high GWP refrigerants. So SNAP issues notices of acceptability and rules. The first, notices of acceptability, is how EPA blesses new refrigerants without restriction, but for certain end uses. So for example, in a recent rule, which we're going to discuss further, the use of 450A was allowed in vending machines. Without restrictions means that there's no maximum charge requirement, for example. A rule goes in the other direction. It states that a refrigerant is no longer acceptable for use in a particular application, or that it's acceptable but only with conditions. So an example there is 134A for motor vehicles. It's been ruled as unacceptable as of model year 2021, but with some exceptions to that ban through model year 2025. So let's cover some of the definitions and terminology we'll be using. We mentioned the term substitutes before, but it bears repeating. Substitute sounds like something that's being added or substituted, but in EPA parlance, substitute means something that substitutes for a CFC or an HCFC, even if it's several generations later. So CFC 12, for example, was a controlled substance. R22, one of its substitutes, was controlled. Then R404A, an R22 substitute, was controlled, as are any future substitutes. So yes, even though it's a substitute, it is being phased out. Another term is delisted. Since EPA once found these refrigerants acceptable by listing them, they are now delisted. Retrofit is another interesting term. We're not referring to equipment retrofit here, but rather refrigerant retrofits, like substituting an HFO in the field where an HFC was previously used. Change out from one refrigerant to another in the field is called a retrofit. And then finally, change of status date. When we talk about bans on a refrigerant after a specific date, we mean that the equipment has to be manufactured before that date. And manufactured means that the day that the refrigerant loop for that system was completed and charged and sealed. The equipment can be sold and installed after the date of the ban, but no new equipment can be manufactured using the banned refrigerant. So let's now look at the two most recent notices of acceptability. We won't look at all the newly accepted substances, but just a representative few. In the EPA notices, you can find a summary of what's been found acceptable, such as 450A, and also a list of the acceptable applications. You can see the manufacturer's submittal document, and if you want to drill further, you can read EPA's assessment of the health and the environmental assessment that led them to the acceptance. In a moment, we're going to take a look at a complete chart of the newly acceptable refrigerants and their applications. So these last two notices, called Notice 29 and 30, should be considered together since they both pertain to refrigeration applications. Notice 29 also speaks out about foam blowing agents, which we're not going to cover here. But it allowed the use of 450 in most everything but retrofit vending and CO2 in refrigerated transport. Notice 30 expanded on the use of 450A and found several other low GWP refrigerant blends to be acceptable as well. Now for the rules, which again find refrigerants that are acceptable with restrictions or unacceptable. And the two recent rules are shown here. Rule 19 allowed the use of certain HFCs in certain applications. Because of flammability concerns, their total charge is limited. For example, propane is limited to 150 grams of charge in standalone equipment. And by the way, EPA does allow the safe venting of hydrocarbons subject to conditions. Rule 20 is the one that delisted many traditional refrigerants. We'll see a list of all of these in just a moment. But first, what is your number one concern regarding the implementation of the rule? Pick one here. Give you a moment to show what you think your largest concern is for the rule. And here's the results. Not surprisingly, costs are number one. Lack of resources and timing, similar to what we're hearing elsewhere. Let's take a moment to talk about the types of systems affected and how the EPA actually defines these systems. EPA in the rule states, for instance, for supermarket systems, that typical supermarket systems are known as multiplex or centralized systems. They operate with racks of compressors installed in the machinery room. Two main design classifications are used, direct and indirect systems. At least 70% of the supermarkets in the U.S. use centralized direct expansion systems to control their display cases. Indirect supermarket designs include secondary loop systems and cascade refrigeration. This is EPA's definition for condensing units. They also call them remote condensing units. They exhibit refrigeration capacities that typically range from about 1 to 20 kilowatts, or up to about 6.5 tons. And they're composed of one or sometimes two compressors, a condenser, and a receiver, assembled into a single unit, which is normally located exterior to the sales area. The modifier remote indicates that the condensers are not located in the space or area cooled by the evaporator, but are instead located outside the room, typically ejecting heat to the outdoor ambient environment. Remote condensing units are commonly installed in convenience stores, specialty shops like bakeries and butcher shops, as well as supermarkets, restaurants, and other locations where food is stored or served or sold. So just important, I mean, they're common definitions, but this is EPA definitions. Standalone equipment consists of refrigerators, freezers, reach-in coolers, either with doors or open, where all the refrigeration components are integrated, and for the smallest types, the refrigeration circuit is entirely brazed or welded. These systems are termed standalone within SNAP because they're fully charged with refrigerant at the factory, and typically they only require an electricity supply to begin the operation. So here's a list plucked right from the EPA fact sheet showing what refrigerants have been delisted for certain applications. And going from left to right, we see the end use, the substitutes, and the decisions, which in these cases are being found unacceptable by the dates shown. One thing we notice here is high GWP refrigerants in the retrofit applications that are shown on 3 different lines here, those that say retrofit, are banned next year. That's basically saying that you can't, say, take a R22 system and field retrofit it with these high GWP refrigerants. You'll have to skip right to the low GWP alternatives. So contractors and end users are going to have to know this. Line 2 says that the new supermarket systems installed after July 1st, 2017 can't use the refrigerant shown. And then the next to last line says that new remote condensing units manufactured and sealed after January 1st, 2018 cannot use them. And here we see for standalone refrigeration systems. Again, we notice a couple of things. The smaller direct expansion equipment and the larger flooded evaporator equipment are broken out separately on the first two lines. We think the EPA recognized that equipment that typically uses flooded evaporators needed more time for redesign to work around the problems with refrigerant glide. Also, low temperature standalone units were given more time until July 1st, 2020 to phase out high GWP refrigerants. And again, on the last line, retrofitting existing systems in the field with high GWP refrigerants are unacceptable as of July 20th of next year. The same with remote condensing units. No field retrofit with high GWP refrigerants after July 20th of next year, and in new condensing units after January 1st, 2018. Likewise with vending machine retrofits, and new vending machines were given until January 1st, 2019. Again, all this information will be in the slides that we send you. Those were the equipment covered by the rules. And what's missing? Well, ice machines, ice cream machines, and beverage dispensers are not in this rule, but we think they're likely to be covered in future rules. Some other notes from the rules. As we stated before, existing systems may continue to be serviced and maintained for the useful life of that equipment using the original refrigerant. And we think original, they mean existing refrigerant. If you have a tight and well-functioning piece of equipment, you do not need to change the refrigerant or take it out of service. New systems, including new supermarket systems, manufactured after the change of status date will not be allowed to use the refrigerants for which the status has been changed to unacceptable. EPA will consider a system to be new for the purposes of the SNAP determinations as of the date in which the refrigerant circuit is complete. The system can function, the system holds a full refrigerant charge, and the system is ready for use for its intended purposes. And then finally, a supermarket may undergo an expansion and continue to use the existing refrigerant if there is sufficient cooling capacity within the existing system to support that expansion. So some other important notes that we've pulled out from the rule. So again, to give me a break for a moment, how prepared do you believe your company is today to meet the refrigerant restrictions outlined by the rule? Again, these are all anonymous answers, so how prepared do you think your company is? No, surprisingly, none of us are too prepared, and many somewhat or not prepared at all. And again, consistent with what we're hearing as we talk to folks in the industry. So again, what refrigerant options are left? Well, here's some of them. There's still some variety, but each has its design challenges. And R32, which we show here, is not an option for refrigerant by itself, but we show it here because it's a component for some refrigerant blends. We've also sliced and diced the information another way, and I'm not going to go through all of this. Again, we'll send this to you as we send you the slides, but this helpful chart of new acceptable refrigerants and the applications for which they were approved is a good way to view some of these rules. This might be a more useful way of looking at the refrigerant options. Here we show the refrigerant with the trade name, where it's appropriate, how it's used, the ASHRAE designation, and a few other comments. The ASHRAE designation, if you're not familiar with that, that's a safety designation. The A or the B in the designation represents toxicity, so how much refrigerant a person could be subject to without toxic effects. And all the refrigerants that we show in our chart are A, lower toxicity. The numbers represent the refrigerant's flammability, ranging from 1, which is non-flammable, to 3, which is highly flammable. And in addition, there are 2 and 2L categories. 2 is flammable, and 2L is mildly flammable. So the refrigerants shown here are either non-flammable, or in the case of the 2 hydrocarbons, highly flammable. And of course, special care needs to be taken in the design of systems and the handling of those refrigerants. So which of the following alternative refrigerants are you considering? You can put more than one answer down. Give you a moment to fill in all your answers. Well, you see far and away hydrocarbons is the most prevalent, and some of the newer blends are shown there as well. None of the above is interesting. We'd love to talk to you afterwards and find out what your plans are. Here we've regrouped the EPA rules and shown them on a timeline. And so from the left to the right, we're talking about field retrofits, supermarkets, condensing units, the smaller than the larger standalone units that can no longer use delisted refrigerants as of the dates shown. Kind of interesting to see it this way. It's also interesting to note that the timeline for any of these changes and redesigns are really pretty short. I mean, this entire range is only about 52 months from today. If you're working to get smaller standalone equipment on the market, you've only got 40 months. Only 28 months for remote condensing units, and a mere 16 months for supermarket equipment. And in those 16 months, you'll need to redesign the equipment, do all your tests for safety and for performance, get your third-party certifications, all your DOE submittals done, work with your marketing and sales staff and everything you need to have to finally go to market. It's a pretty daunting task. So, where do we think the commercial refrigeration market is headed in North America? Danfoss believes that some of the recently allowed blends are really good transitional refrigerants, but we don't think they're the ultimate step. And I think from seeing your responses to this, you probably agree. Long term, we think commercial refrigeration will rely upon low GWP refrigerants such as hydrocarbons, CO2, which is noted here as R744, as well as HFOs. And Danfoss has experience with all of these. Before ending, I'd just like to point out some additional considerations. First, the AHRI AREP program, the Alternative Refrigerant Evaluation Program, is a voluntary effort into which Danfoss and many other industry players, including maybe your own, are contributing data. AREP is testing various refrigerants and refrigerant blends, and the resulting reports are, and should continue to be, a good source of performance data. So see the AHRI website for more information on that. Second, be aware that A2L refrigerants are not yet covered by the building codes in North America. Currently, ASHRAE members are working on an update of the refrigerant safety standard to include A2Ls. Danfoss is facilitating meetings of a wide-ranging group of stakeholders that are devoted to expediting the code adoption process for A2Ls. Still, the code coverage is quite a way off. And then finally, if you haven't heard, the AHRI suit against DOE for walk-in coolers and freezers has been settled. Starting at the bottom of this chart, refrigeration standards for multiplex condensing systems at medium and low temperatures and for dedicated condensing systems at low temperatures will be vacated. DOEs will support the use of a negotiated rulemaking process concerning the vacated standards with a target completion date of January 2016 for that negotiated rulemaking process. And as to the first note on the right side of this chart, DOE will be making it clear that it will not enforce the walk-in cooler freezer refrigeration standards until January 1st, 2020, provided that the negotiated rulemaking gets done in time. The walk-in cooler freezer standards for doors and panels is not affected by this settlement. So there you have it, a review of the new SNAP rules and their implications for your products. The manufacturers of commercial refrigeration equipment provide products that are vital to our society and to our well-being, and we are dedicated to helping you to comply with these rules. So bottom line, here's what we recommend you do. First, since the new regulations take force on July 20th of next year, make sure you inform your sales staff, your distribution chain, and your contractors about the impending restrictions on field retrofits. They need to know about that. Next, get serious about product redesign if you haven't already. Visit our refrigeration and our air conditioning site, the link of which is shown here. Danfoss has extensive experience with product and application knowledge that can assist you in your efforts to understand and to comply with these new rules. In addition to this link shown here, we encourage you to contact your local Danfoss representative to continue this dialogue. And if you need help in identifying your representative, contact Chris Nitz directly. His link is shown here, and he'll be happy to assist. We're going to take your questions in just a moment, but first, one last question. Again, on a scale of 1 to 5, rate your level of familiarity of the details and the implications of the SNAP rule now that this webinar is complete. Whoops. And, well, I think we may have raised the level of understanding at least a little bit through the seminar. Very good. Michael, I'll turn it over to you, and I think we'll take some questions.
All right. Thank you, Mark. So if you have any questions, please submit it now. Thank you to everyone who has already submitted them. And we have our panelists here with us, so let's answer some of your questions. The first one was, what is the definition of retrofit?
Yeah, I'll take that. This is Steve Spletzer. Basically, when we say retrofit, what we're talking about here is the refrigerant retrofit. Removing the original or existing refrigerant and replacing it with another product. So, for example, we could be talking about R22 systems being retrofitted to 404A. That's something that's happened in the past. Or, in the future, going to 407A.
All right, great. Thank you, Steve. The next question is, why are the ice makers and soft serve exempt from the ruling?
Well, one of the things about these rulings is there's a lot of focus on trying to make sure that there are reasonable solutions and alternatives in place. And for the products that were approved and the applications that were targeted, that's generally the case. Ice machines and soft serve machines aren't included here. They may be subject to future rulings, but there are some technical issues and challenges that the industry is facing right now with potential alternatives. R290, for example, a lot of people are looking at that. For a lot of ice machines, the charge size would be too large with the current 150-gram limits that are out there for other applications. A lot of the other alternatives that are approved here are high-glide blends, and they're really not suitable for ice machines, particularly cubers, where uneven temperature in the evaporator can affect the ice cube formation. So When better alternatives are in place, I think you will see those applications be focused on as well.
All right. Thank you, Steve. The next question is, why do we keep having these refrigerant changes? Can't we just jump straight to natural refrigerants and be done with it?
That's a good question. Well, the reality is there is no one group of refrigerants out there that is going to be the perfect solution for all these different applications. And the fact is, we have to consider things like safety, environmental factors, and energy efficiency to make sure that we're focusing not just on GWP, but the life cycle climate performance, for example. And there is a huge installed base of equipment out there that can't simply be retrofitted to natural refrigerants overnight. And there are a lot of equipment design issues that have to be worked through. So right now, there are a lot of research going on. There are advancements in technology that are allowing for the use of new products like HFOs. These are also expanding the application range of hydrocarbons and CO2. And we think this trend is going to continue. And long term, you'll probably see that our industry will ultimately rely on low GWP refrigerants like HFOs, hydrocarbons, and CO2 as their preferred solutions.
Okay. Next question. Is there any movement to raise the charge limit for R290 from 150 grams to, say, 300 grams?
I think that's something that's being looked at. Whether or not that's going to happen remains to be seen.
Yeah, this is Jeff. To follow up with that, it's something that will absolutely occur. And actually, it's not that there's a restriction just on 150 grams. It's applied to the application. So if you look at, let's say, household refrigerators for flammable refrigerants, the charge limitation is 57 grams. For most of the self-contained commercial refrigeration applications, that's where your 150 grams comes into play. However, there's other applications where they've looked at for mini-split applications where the charge limit is beyond the 150 grams. They view that as a safer application where you can actually have the combination of the amount of air that's present with the propane, you can allow for a higher charge. So typically what you're going to look at is what sort of environment can this application be placed in, how much of an area of the mixture of air in the room combined with the total charge of refrigerant. So it's absolutely something that's considered. To go beyond the 150 grams, that's typically where the EPA will look for any tips or help from UL or some of the safety agencies that are out there to perform testing and really look for industry tests as well to say, is it safe to go beyond there? And I think if the industry agrees upon the safety level of the charge for a given application and the placement of that application, then I would be willing to bet that the EPA would accept larger charge for the A3 refrigerants.
All right. Thank you, Jeff. Can you please add some clarity to whether R134A can be used for standalone units as a retrofit beyond July 2016?
Sure. If you look at the SNAP fact sheet for Rule 20, what you're going to see is that only 404A and 507 are listed as unacceptable substitutes. So based on that, yes, 134A can be used past 2016 for retrofitting in standalone units. However, keep in mind, though, that for new medium temp standalone units, R134A is being delisted come 2019 and 2020, depending on the BTU rating and the evaporator design of the system.
Okay. Dean, I think this one's for you. What new refrigerants have been approved on what Danfoss hermetic reciprocate compressors?
Okay, so a lot of that is in process right now. Currently, they are approved for 407A and F, and also in process are the qualification of R448A, 449A, 452A and 513A, and those will all be approved here by the end of 2016 mid-year.
Okay, thank you, Dean. This is a long one, so bear with me. There seems to be some confusion around how remote condensing units are treated when it comes to effective delisting dates and what is considered new under this SNAP ruling. A typical condensing unit is field installed and not charged until then. Does this mean we can keep making condensing units for field charging after the delisting date and still comply with the rule?
Good question. This is something that we're in the process of following up with the EPA. I think we think it's unlikely that remote condensing unit manufacturers are going to be able to indefinitely manufacture equipment based on delisted refrigerants. But as soon as we have feedback on that, we'll get back to you.
Okay. I think we have 3 more, unless anyone would like to continue to submit questions. We have about 20 minutes left in our scheduled time with everyone today. The rule states that it does not affect the serviceability of existing systems. Are condensing units part of a system and thus could be a service item?
That's another good question, and similar, I guess a similar response to the last one. That is one possible interpretation. We have asked the EPA to clarify this point, and when we hear back, we'll let you know.
Great. In Rule 20, the EPA lists an argument for the delisting R448A and R449A for standalone systems, while in Notice 30, they have yet to be approved for medium temp systems. So is there a conflict?
Yeah, there does appear to be a conflict in these 2 items. We have asked the EPA for clarification, and again, this is another one situation that when we hear back, we'll be able to respond better to your question.
Okay. And our last question for today. There's been some confusion as to how to interpret the reason for EPA's splitting out the medium temp standalone units in terms of BTU per hour and flooded or non-flooded evaporators. Can any of you guys provide any insight here?
Yeah, we had I guess a little bit of the same confusion ourselves, and we've been in contact to find out what the rationale is. And basically, what we found is the issue was brought up that for equipment using flooded evaporators, many of the lower GWP alternatives are high glide, and that can be problematic for flooded evaporator systems, and there are a lot of design challenges that go along with making flooded evaporators work. So because of that, they require additional time to address that, and that's why they have the January 1st, 2020 change of status date for new standalone equipment with flooded evaporators.
Okay, great. Well, I will pause a minute if anybody else has any questions they would like to submit. Okay, well, thank you everybody for attending today's webinar. As mentioned earlier, the webinar has been recorded and you will receive today's session soon. When the webinar ends today, you will receive a survey, or a survey will pop up in your browser, and we hope you will answer these questions completely and honestly. So thank you again, and on behalf of everybody here, have a great day.